Bismillahirrahmanirrahim, ladies and gentlemen. I hope you are in healthy. Today we are going to talk about a very interesting topic, that is molecular orbital theory for tetrahedral complexes. In this case, you know that geometry for the tetrahedral molecules is tetrahedral. So in this case, the coordination number in these complexes is 4. The secondary valency is also 4, which is also compared with the coordination number. The ligand attached is in this case is weak. That's because if it has a strong ligand, it will give result in case of square planar complexes. So that's why here is in tetrahedral complexes the ligand attached is weak. So in this case we have taken an example of tetrachloronectate. The atomic number of nickel is 28 and the oxidation state of nickel is +2. So that's why the configuration, the electronic configuration is 4s2 3d8. But if you know that in this case it is +2 oxidation state, so that's why the 2 electrons are removed from this s1. So the primary valence is also known as the oxidation state is also 2. So now you know that in this case the electron will be filled in 3d and 4s remain empty, 4p remain empty. So these are electrons filled over here. Now here the chlorine will donate its lone pair or its bond paired to these orbitals. So now you can see this hybridization is now sp3 hybridization, and you know very well this sp3 hybridization is found in those compounds which have tetrahedral geometry. So now moving swiftly on to this few points. If you have studied a little bit about group theory, but if you don't have studied, then let me know in the comment section. I'll explain it also. In group theory designation, we have some designation for this SPD. So the first one is A for S is A1, for PX, PY, PZ is T1, for DX, DY, DYZ is T1, for DZ square, DXY square, dx square minus y square is E. That's because if you will have a confusion that in octahedral complexes I have talked about GU, and here I haven't written about GU. That's because in octahedral complexes, octahedral molecules have symmetry. There is presence of center of symmetry or plane of symmetry. So there's a symmetrical. So this symmetrical and unsymmetrical, we talk about in that case of a Girard and unGirard. Some people call it as Girardi and some people call it unGirardi. So that's why in tetrahedral complexes have symmetry. So that's why we discussed Girard and unGirard. In that case, you know that I have written over there A1G, T1U, T1U, EG. But here, no, that's because this is a tetrahedral structure which don't have center of symmetry. So now moving swiftly on to its molecular orbital theory, molecular orbital representation. Now you know very well that here we have 3d, 4s, 4p, and this is the ligand electrons. So that's why now in this case the 4s, this is electrons are donated to 4s. Now this is the 4s filled in bonding, and you know in the quantum concept that there is the possibility of bonding. There is also a possibility of formation of antibonding. So the bonding electrons are filled to the bonding. So that's why electrons and antibonding remain empty. So now this is A1, which is group theory representation for S. For 4p, here 6 electrons are donated to over here, 3 lone pairs. So that's why its antibonding will also remain empty. The d-splitting occurs in this case is in the form of E and T2. So the T, you know that if you have studied about CFT, the splitting is in that case. If you don't have studied at that, let me know in the comment section. I'll explain it in detail at why this occur in this case and why octahedral complexes have E above and T below. I will explain it there. So this is A1, this is T1, this is T1 star, A1 star, T1 star. That's all about this representation, MO diagram. If you have any confusion, you may ask in the comment section. It will elicit appreciation. Remember me in your praise. Allah Hafiz.